Okay, well, section 2.2, geometry. We're going to be learning about some conditional statements, and actually you've heard a lot of them already in your upbringing. I'm sure you've heard your parents say things like, oh, well, if you clean your room you can have these cookies, or something like that. So basically a conditional statement is an if-then statement, but in mathematics we're going to explore that a little bit more closely and be a little bit more rigorous about our definition and things like that. So let's find out what that's all about. So here we go. Analyze conditional statements. So one thing you should think about is that it's called a conditional statement because a condition must be met before you reach the conclusion. So let's just look at the parts of a conditional statement. We'll be getting that soon. So our objective today will be, students will be able to construct the converse, the inverse, and contrapositive from a conditional statement. So the essential question is, how do you write conditional statements? And how do you construct the converse, the inverse, and the contrapositive from the conditional statement? So we'll sort of be practicing this. This will almost seem like an English class today, but this is actually an important branch of mathematics because it has to do with logic. And then of course logic is used to diagnose problems all the time. So we want to be pretty good at creating logical statements, and we also want to learn a little bit about which logical statements are true and which ones are false, so that way we can watch out for those kind of things when we create arguments mathematically. So that's part of our objective as well, is just to understand them a little bit, not only just write them. So what is a conditional statement? Well, it's a logical statement that has two parts, a hypothesis and a conclusion. Now, for simplicity, we will be using, I'll be using some letters to help you keep this straight. So like, for example, a hypothesis, we'll use the letter P and we'll use letter Q. And logically, we're going to explain what a converse is and what an inverse is, what the contrapositive is, and we want to be able to write all of these. And it will be a lot easier if I just explain how to do it in terms of P's and Q's. You'll see this later on. So anyhow, the hypothesis will refer to P, the conclusion will refer to Q. And it's pretty easy to recognize these because the hypothesis always comes after the if part, and the conclusion comes after the then part. So it'll be easy. We're going to look at some here in just a moment. So let's get back to the lesson. Well, let me back up. That was a little fast. So the if part. We have the if-then statement. The if part contains the hypothesis. The then part contains the conclusion. Now sometimes we have an if-then statement that's not really written in if-then form yet. So we're going to learn how to deal with that in just a moment. So here's a statement. It's kind of a conditional statement, but it's not written as a conditional statement. So let's practice doing this. You'll have a couple of these on the assignment. So let's see. The statement here it says all birds have feathers. So how can we write that as an if-then statement? Well, we'll do part A right here. So we need an if and we need a then. So if what? That's going to be kind of tricky because sometimes you have to add words to the original statement. So I'm going to say if an animal is a bird, if an animal is a bird, comma, then it has feathers. Okay, so this would be what we call a conditional statement. Now, there's, like I said, there's two parts to this: a hypothesis and a conclusion. So this portion right here is your hypothesis, and to state this a little bit shorter, we're going to use the P and the Q. So this part here would be the P, and this is also what we're calling the hypothesis, and I'm going to abbreviate that hypothesis HYP. Okay, the second portion that comes after the then is this part here. Yeah, it has feathers. That part right here. This mumbo jumbo up here. That's your conclusion. So notice that this condition must be met before you kind of read on to this part here. That's why it's called a conditional statement. Okay, so in any event, this is what we'll call Q, and this of course is the conclusion. So well, so that's how we do the first one. Let's go ahead and try the second one now, part B here. Again, what we want to do is start off with the if part. Alright, so let's see. Two angles are supplementary if they are a linear pair. And it's almost like they have the if part in there, but they're missing the then part. And so this can be kind of tricky, so it's almost tempting to write if they are a linear pair. And so I don't, then you go, well, where's the then? So here's how I think we should do it. If two angles are, now hold up a second. What I was going to say is if two angles are supplementary, then they form a linear pair, but that wouldn't be true, because remember when we learned about supplementary angles, they don't have to be touching. I mean, you could have another angle over here. This angle could be 150, okay, and this one could be like 30, and those angles would be supplementary, but they don't form a linear pair. Remember, a linear pair will always have they form a line. Okay, so there's always a line involved, and so a linear pair looks something like this. You might have an angle here where this one's 40 degrees, okay, and remember, a linear pair also has two angles where they have a shared side, or they're adjacent. The angles are adjacent to each other. So this angle would be like, say, 140, and together they add up to be 180. And you'll notice there's always a line involved. There's a straight line right here. But I think for this to be a conditional statement, we have to state this part first. So let's start out a little bit different way and say, well, let's start out like this. I'm going to switch colors now. Switch colors here. Let's start out like this. If two angles, okay, form a linear pair, and now let's write the word then. Then they supplementary. And I'm going to abbreviate supplementary. Supplementary is SUPP, supplementary angles. Okay, so that's how we could create the conditional statement for that one. So some of these are a little bit tricky on how you write these. You may have to think about it a little bit. You'll find out that in some cases it really doesn't matter which one's the P and which one's the Q. You might say, well, it's true either way. In this case, it does matter a little bit here. You need to have the linear pair first, and then you have supplementary angles. So you might have to think a little bit about how to write the statement so that's true in a sense. So there's a couple examples. All right, so and here we have it right here. These if an animal is a bird, then it has feathers. If two angles are linear pair, then they are supplementary. Okay, so let's move on. Now, from the conditional statement, we're going to start writing other sorts of statements. Maybe we could practice this a little bit here. Take a moment to write these on your own. Give you about 2 minutes, and you can write them on your own, and then I'll see if I can come up with the answers as well, and we could discuss this a little bit. Alright, I'm going to assume that you're done now. Let's see. Let's do a couple of these together, okay? Maybe we could do all of them, I don't know. Okay, all 90-degree angles are right angles. Okay, so what we want to do is write an if part and then a then part. So maybe for this one we can say if an angle is 90 degrees, then it is a right angle. Okay, so if an angle is 90 degrees, then it is a, and I'm going to abbreviate right angle like this, then it is a right angle. Okay, so that takes care of that one. That one's pretty easy, right? Number one. Number two, how can we do this one? Now, by the way, it can be tricky writing this one because I think you can write it either way as the if part and the Q part. I think we can consider this to be a hypothesis or this one to be the hypothesis, and it'd be okay. So I don't know, it can be tricky sometimes. So here's how we could write this one. Let me switch colors. Okay, so if 2x plus 7 equals 1, then x equals -3. Alright, now here's the thing you have to be careful about. Sometimes when you write if-then statements, the statement doesn't necessarily have to be true. I think in this case it is, because if we were to move the 7 across, we would subtract 7, and 1 minus 7 would give you -6, and then you divide by 2, which would give us x is equal to -3. But just keep in mind, when you're creating a conditional statement, it doesn't necessarily have to be true. So like number 3, for example, I mean, it helps if it is true, but that's not a requirement, so to speak. So anyhow, I guess as far as homework goes, try to make it a true statement if you can, but keep in mind that it may not be completely necessarily to write it that way. How about this one? When if n is equal to 9, then n squared is equal, yeah, we could do that one, that makes sense. Okay, so if n is equal to 9, then n squared is equal to 81. Okay, so that's how these work. So let me see here. Number 4, switch colors now. I'll try red here. Number 4 we'll put right here. Alright, so how do we want to write an if-then statement here? Okay, so if a tourist is at the Alamo, then they are in Texas. Alright, well, if a tourist is at at the Alamo, then they are in Texas. Whoops, Texas. Well, maybe I should write that out. Okay. In Texas. Alright, so we've written them now as if-then statements. So there's a little bit of practice, so hopefully everyone feels comfortable doing that. You'll have to do that on a few problems on your assignment as well. But let's move on and find out what the converse is, the inverse, and the contrapositive. That's coming up next here. It's coming up next after negation. Alright, well, the bottom line is we need to know what negation is before we create the inverse, for example, because the inverse involves negation. So what is negation? It's just basically the opposite of what the original statement was. So think of it as a negative, but it's just simply the opposite. So if the original statement was stated in the negative, then the negation would be positive. So it's just the opposite of whatever you had. I should say that from a logical standpoint, there's a common symbol we use for negation. It's this symbol here. So that symbol in mathematics means not. Okay, so let me give you an idea. If you wrote a statement, if P, then Q, this is typically how we write logically a conditional statement. If P, then Q, where P is the hypothesis and Q is the conclusion. So logically what we do sometimes is we say, well, if not P, we use this negation symbol, and sometimes we'll say then not Q. Think of it as like the negative sign. But anyhow, that's the symbol we use for negation, and I'll show you more of this later on. Okay, so let's continue. It's pretty easy to write a negation. Sometimes you just add in the word not. And so let's practice doing this. How would we write the negation of this one? Well, this one would say the ball is not red. On the other hand, this one is stated in the negative, so the negation of this would mean the affirmative or the positive, so to speak. So on this one, we'll state the cat is black. Okay, so that's not too hard. It's just the opposite of whatever the statement was. Don't think that the negative always has the word not in it. It may have the word not, depending on what the original statement was. Okay, so to create the converse, we exchange the hypothesis and the conclusion. So basically, from a logical standpoint, the conditional looks like this. The conditional it looks like this. If P, then Q. Okay? If P, then Q. So the converse just switches the hypothesis and the conclusion. So in this case, we'd write if Q, then P. Now, as we work through these extra statements here, the converse, the inverse, the contrapositive, we're going to find out that some of them will be false and some of them will be true. And we want to keep note of that because, like I said, part of mathematics is the ability to argue correctly. We're going to want to prove certain things. And so when we're creating a logical argument, we want to avoid making these mistakes. We want to avoid doing the converse, for example, because the converse is not necessarily true. Let me give you a quick example, okay? So here's a quick example. If I have a Corvette, then I have a Chevy. And that's because Corvettes are made by Chevrolet. But let's say we try to switch things around and I write the converse. If I have a Chevy, then I have a Corvette. Okay, well, as you might imagine, Chevy actually makes several different types of cars. They even make trucks and stuff. So I could have a Chevy Impala or Chevy Pinto or a Chevy Silverado, or maybe a Chevy Malibu, for example. So when the statement might be true but not entirely true, as the original statement was, then we say that this one is false. We would say that this one's false. And the original statement we would say is true. Okay, so keep that in mind. The converse often is not true. It can be false many times. So in essence, we want to avoid using the converse in place of a conditional whenever we're creating a constructive argument or a proof of something like that. This will become more important when we do proofs later on in the chapter. Okay, so let's get back to their lesson. All we do is switch to 2. And what I want to do is summarize these 3 here. The converse, like I said, they switch to P and the Q. So here's the original conditional statement, P and Q. The converse just switches. The Q goes first, and then this one comes second. Alright, so another related statement to the conditional is what we call the inverse, and that's when we try to negate both statements. And basically we put not P, then not Q. Now, in my Corvette statement, the Corvette statement was true. If you have a Corvette, then you have a Chevy. On the converse, we said if you have a Chevy, then you have a Corvette. Well, that one we would say is false. Okay, and if we look at this statement here and we go to my Corvette example, this one would say if I don't have a Corvette, then I don't have a Chevy. Well, as you might imagine, that's not necessarily true. I have a Silverado, and that's not a Corvette, but it is a Chevy. So, as you might imagine, the inverse can be false also. And on the other hand, this one says if you don't have a Chevy, then you don't have a Corvette. And that would be absolutely true. And so often when we're creating these sorts of statements, you'll have this pattern. Now, you won't always have this pattern, but here's the deal that always does happen. These two are always the same. Okay, these are always the same. And these two are always the same. Okay? And so that's what will happen. So either you could have true, false, false, true, or you could have true, 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 or you can have false, 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 or you could have false, true, true, false. So that's kind of tricky sometimes, and we're going to need to practice this. And we're going to do some problems here where you're deciding for yourself whether they're true or false. But one thing you won't have is true, false, true, false. Like I said, these two are either both true or false, and these two are both true or false. So we'll practice that here with some examples. All right. So let's look at this from a logical standpoint. Since this is your hypothesis, we'd call this P, and this part here Q. So what we're going to do is we're going to create the converse, the inverse, and the contrapositive, and we're going to see that all we need to do is just move these around. So to create the converse, notice what happened. The part that was here moved first, and the part that was here moved over here, so they just switched places. So now the statement says Q, and then P is over here. Alright, so now let's look at the inverse. Now, all they did now, it's like the original statement, but they negated it. And so this symbol here means does not equal. Does not equal. And so what we have basically here is not P. Excuse me. If not P, then not Q. Oh my goodness. I'm allergic to math. And so you see this portion here. There's the not, okay, and then there's the Q part, basically. Basically Q is obtuse. So if you negate both parts, then you have what's called the inverse. Alright, so we have the contrapositive, the inverse, and now let's look at the contrapositive. Now, the contrapositive is just like the converse. However, both parts are negated. So, from a logical standpoint, we write it this way. If not Q, then not P. And once again, let's check the true and falseness idea here. And you'll find out what I said before on the previous slide. These two are always the same, and these two are always the same. So let's check that out and see if it's true. So if the measure of an angle is 99 degrees, then it's obtuse. Well, yeah, because obtuse means that it's an angle greater than 90 degrees. So we would say that, well, this one's true. Okay, if an angle is obtuse, then the measure of the angle is 99 degrees. Well, that's not necessarily true. I mean, it could be 120 degrees. It could be 91 degrees. It could be 92.7 degrees, and so on and so forth. So since it's not necessarily 99 degrees, we would say that this one's false. Okay? Well, now we say if an angle is not 99 degrees, then it's not obtuse. Well, that's not quite true, because the angle could be 92 degrees and then it would be obtuse. So so anyhow, we would say that this one's false. Now let's look at the contrapositive. If angle A is not obtuse, then it's certainly not 99 degrees. And that would be true, because it would also be not a whole bunch of other angles as well, but it's certainly not 99 degrees, because in order to be 99 degrees, the angle would have to be obtuse. So we would say this one's true. So notice once again that these are both together. They're always going to be the same, and these two are going to be the same. And there you have it, both false, both true. Okay, so, whoop, hold up, back up there. So what we want to do is practice here a little bit with this statement here. We want to create the original conditional statement. Well, they have the conditional. They haven't written in an if-then form yet. So what we'll want to do first of all is write this conditional statement. The conditional statement's right here. Guitar players are musicians. We'll want to write that as a conditional, and then what we want to do, write the converse, inverse, and the contrapositive, and then we want to decide whether they're true or false. Okay, so let's write if. Okay, so how should we write this? If a person is a guitar player, that's how I think we should write it, then they are a musician. Okay, so if a person, now notice I have to add in some words just to make some sense here. If a person is a, whoops, back that up, is a guitar player, then they are a musician. I'm kind of running out of room. I'll move this over here to this side. Musician. Okay. So there we have our basic construct. So this portion right here is the P, and this portion is the Q. So from a logical standpoint, to create the converse, all I want to do is switch the two around. Alright, so what I want to do now is use a different color. If a person is a musician, then they are a guitar player, right? Okay, so what we did was switch the P and the Q around. And as you might imagine, some of these are going to be true and some of them are going to be false. And so I would say our original statement was true. But in this case, if a person is a musician, then they are a guitar player. Well, that wouldn't necessarily be true because they could play the piano, they could play the tuba, the cello, or violin, or flute, and so on and so forth. So I would say that this one is false. Okay. Well, now we'll do the same process just with the inverse instead. So the inverse, what we need to do is negate both of these statements here. So all we need to do is add the word not, basically, and we can get the inverse. So if a person is not a guitar player, then they are not a musician. So what do you think? Does that sound true to you? So we've added in the word not in both of these cases, for the P and the Q. But certainly if a person is not a guitar player, like they could be a pianist or a celloist or so on and so forth, that they're still a musician. So this would make this statement false. And as we've seen in the past, these two are typically going to be the same, and the last two are going to be the same. So without even writing it, I'm pretty sure the contrapositive is going to be true here. But let's confirm that. What we need to do is write the converse right here. It's the same thing as the contrapositive, but we just need to negate it. So in this case, we just need to add the word not in there. So if a person is not a musician, then they are not, then they aren't a guitar player. And I think we'd have to say that's true, because if they're not a musician, that means they don't play any instrument. Then they can't be playing a guitar then, because if they were playing a guitar, that would make them a musician. So this seems logically true. So we've stated each of the statements. Right here's the converse. The inverse is right here, and the contrapositive was right here. So, and then we decided whether each one was true or false. So you're going to have one of these or a couple of these on your study guide, and I'd recommend, if you have your study guide out, to go ahead and do that right now so that you get some practice, and then we'll move on with the rest of the lesson. So go ahead and do that. Take about 5 minutes. Do that now before you forget. Okay, so moving on with the lesson, let's discover a few more things. Alright, let's just read this together. It's not terribly deep, and it's pretty obvious, I think. A conditional statement and its contrapositive are either both true or both false. That's something I've said already. Similarly, the converse and the inverse of a conditional statement are either both true or both false. Pairs of statements such as these are called equivalent statements. What we say in this regard is that they're equivalent logically. Obviously, they're not the identical statements, but we say they're logically equivalent. So in any event, it says, in general, when statements are both true and both false as they relate to the converse, inverse, and contrapositive, and so on, then we say they are equivalent statements. So that's straightforward. Let's move on. Alright, so we have a new definition thrown in this lesson. I'm not sure why it goes here, but in any event, we will deal with it right now. If two lines intersect to form right angles, then they are perpendicular lines. So, maybe we could draw a picture of this. If two lines intersect to form a right angle. So here's a line here, and we have another line come across this way. Alright, they form a right angle. So there's a right angle in here. Means that the right angle means that the measure of that angle is 90 degrees. Okay. Well, what we're saying is that a measure equals 90 degrees, and it means that the lines are perpendicular. So there's the symbol we use, perpendicular. I might add that there's a common symbol we use when we're writing things. We use this symbol here for perpendicular. Okay, so what we'd say is line L is perpendicular to line M. Remember, we could use a lowercase script letter to refer to lines. So this might be line L, and this might be like line M. And so that's how we write the statement. Okay, we'll just use this symbol right here. Okay, let's go back. And here's a picture. Alright, so now let's do some logical questions about this theorem or about this definition. Decide whether each statement about the diagram is true. Explain your answer using definitions you've learned. Okay, so first of all, what we want to say is that AC is perpendicular to BD. AC is this line, is perpendicular. Well, okay, now the fact that we have this symbol in here means that we have a right angle. And this definition up here says if two lines intersect to form a right angle, then they are perpendicular lines. So we'd say true, because of the definition, because of the definition. And I'm going to abbreviate definition like that. Definition of perpendicular lines. Okay, definition of perpendicular lines says that right here. If you have a right angle, then they are perpendicular. So that's kind of ugly. Alright, so let's get going again. How about the second part? Angle AEB and CEB are a linear pair. Oh, let's take a look at that. I'm going to erase some of this stuff so I can see a little bit better here. AEB. Well, AEB is this angle. Okay. And CEB. Well, that's this angle over here. And you'll notice that they do have a common ray here, or common side. And the two other rays are opposite rays. One goes this way and goes to the left. The other goes to the right. And there is your line right here. There's your line. Okay. And so, indeed, these two angles form a linear pair. That's what linear pair means. So, let's say true. And by the way, because of that, we could say that those two angles add up to be 180 degrees. Right? Because we learned earlier that linear pairs are supplementary. Alright, well, how about this final phrase here? Or this final statement. EA and EB are opposite rays. Okay? EA, well, that's this ray going this way. And EB, oh, EB is going this way. Okay, they do have the same endpoint, but they don't form a line, do they? And so they're not opposite rays, so we'd say false. Because they don't form a line. And opposite rays, they always have a common endpoint, and they are part of a line to begin with. So anyhow, I'm not sure I need that there. Okay, so there you have it. Some questions, some good practice. All right, now we're at the final idea of this lesson, and that's what we call a biconditional statement. Now, sometimes when you write a conditional statement, the converse will also be true. And in that case, all four of those statements would be true. The converse would be true, the inverse would be true, the contrapositive would be true, and the original conditional statement would be true. And if that's the case, then what we can do is write a biconditional statement. And biconditional, we use a symbol for it. I'd like to show you it real quick. Biconditional statement goes this way. And so basically what you have is an if P then Q. Now logically we write the conditional like this: if P then Q. That's how we often write it. This symbol here means then. Okay. Now hopefully this symbol makes sense. What it's saying is that if you switch the P and the Q, it will be true also. And so the converse would be if Q then P. Well, this symbol up here combines both of these statements into one statement. And when we do that, we use this little phrase with it. We always use this little phrase, if and only if. And that if and only if means that both the conditional statement and the converse is true. And that's what it says here. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. And that just basically means you're going to write it in terms of if and only if. So that's our final objective in this lesson, is to be able to write a biconditional statement. And it just basically means that you're going to have an if and only if. So let me, since I don't have an example of that, I will help you out with your study guide. Your study guide has one of these, so let me do one of them on your study guide. So let's go ahead and end the PowerPoint, and let's look at your study guide. Alright, so here's an example here. Rewrite the definition as a biconditional. Now, the interesting thing about an if and only if statement, when it's biconditional, the if and only if part goes in the middle of the statement. So first of all, let's make sure that they're both true. If two angles are complementary angles, then the sum of their measures is 90 degrees. So if we were to switch this around, if two angles sum is 90 degrees, then we say they're complementary. Well, they're both true, and so what it means is that we can write this statement as a single statement, combining these both together as a biconditional. Here's how it works. We need to have the if and only if part. If and only if. So here's how it works. Normally when you write an if-then statement, the if part comes first and then the then part. When you're doing a biconditional, here's how it works. Okay, so I'll try to do this here. If, oh no. We start out with just two angles. Two angles are complementary. And now you put this if and only if, and it goes right smack in the middle. If and only if, well, I should write that with the lowercase. If and only if. And then you write the second part. If and only if their sum is equal to 90 degrees. Okay? So I've kind of abbreviated that a little bit, but so anyhow, when you write a biconditional statement, the if and only if part basically goes in the middle of the statement, and then you kind of combine both of the statements into one. You write the first statement and then the second part, and you join them together with the if and only if. Try that with the second one. I won't help you on this one. It's part of your study guide, but I think you can get it. Alrighty, well that concludes my lesson, so we'll see you tomorrow. Now here's the deal, we're going to skip section 2.3, so don't be surprised tomorrow when we're doing section 6.4. 6.4, I mean 2.4. Alright.